Now, what is internal energy? So the internal energy is the sum of molecular kinetic and potential energies in the frame of reference relative to which the center of mass of the system is at rest. Just looks a little bit complicated definition. So simply we can say that it is nothing but the kinetic energy associated with the all the molecules. Yeah. So that is what we can say in short. So this is the internal energy for that your system. So this system, let's say, which consists of your lot of molecules. Yeah, so all the molecules, they are in a random state of motion, so they possess some kinetic energy, and at the same time if we consider about the potential energy, they consist of potential energy by virtue of its motion. So the addition of that all this energy constitute of your internal energy over here. Yeah, so this is how we can just show over here. So these are nothing but the types of system and the internal energy from the atoms and molecules contained within your system over here. So now what is the heat? Heat, obviously it is a form of energy that flows from one body to another body due to difference in the temperature, known as a heat energy over here. The work done, so obviously this is also interesting. So let's consider the gas which is enclosed in this chamber, and I'm just going to provide the heat to this gas. So the molecules will get the energy. As soon as they get the energy, they just starts to vibrate with greater amplitudes. Their kinetic energy has increased, so they are going to exert the force on this piston, and let's say the piston will move through a certain distance in the upward direction. So that means the work is done by the gas. The work has been done by the gas. So this is what we can say that about the work done. Yeah, so this is the energy transfer by the system to another. Yeah, by the changes in the external, that generalized mechanical constraint, that is what we can call it as a work over here. So this internal energy, just we can say that, so this is that potential energy, kinetic energy, molecular potential, molecular kinetic, due to intermolecular forces and due to that interatomic force vibrations. And again the kinetic energy, if we go in details, so it might be because of your translation, rotational or vibrational. So the addition for all these energies will give you the total kinetic energy. Yeah, so this is nothing but we can say about the internal energy for the system over here. So what are the different sign conventions that we can use in case heat is absorbed by the system? So that has to be positive, and in case the heat out given by the system, you have to consider it as a negative. Again, in case of work done, work is done by the system is positive, work done on the system it is negative over here. So again, in case of internal energy, so in case of internal energy, when the gas, so when it is heated, it will, the molecules will receive the energy from that external source. Then we can say that their internal energy is going to increase. So in short, if the temperature is going to increase, the internal energy is also going to increase, and if you extract out the energy, their internal energy is also going to decrease. Yeah, so this is increase in internal energy and decrease in internal energy of the system. If the temperature get increase, there is an increase, and if temperature drops down, there is a decrease in the internal energy of the system. So that is what we can say about the internal energy. So this is the indicator diagram, which is obviously again a very useful. Yeah, so let's say the particular system, the thermodynamic system, so which is at a particular state having a pressure P1, V1. Now if I just expand that system, if I expand the gas in the cylinder, so if I expand it, definitely its volume is going to increase by providing some energy externally. So its volume is going to increase, but at the same time its pressure has also drops down. The pressure has also drops down over here. So we can say that, so the pressure drops down over here, volume changes from V1 to V2, pressure drops down from P1 to P2. So this is called as a case of your expansion. Again, in case of compression, if you observe it carefully, so let's say I'm just going to compress the gas. Yeah, so I'm just going to compress the gas So if I consider the gas in this piston, and if you apply the force, so there is a gas, so obviously the gas just now get compressed. Yeah, so this is going to compress, so the pressure is going to increase and the volume is going to decrease. And for the first case, simple, I can say that when you provide the heat to this gas, yeah, so this piston is going to move in the upward direction. The gas is going to expands and the piston will move in the upward direction. So that is what we called it as a case of your expansion over here.